First question here is an integration question, but we're trying to find the upper limit. Well, let's just integrate as normally and then substitute in and then we'll create an equation. First thing I'm going to do is replace root x by x to the half, so it's a power. And then I can use the fact that the integral of x to the n, we raise the power by 1 and divide by that new power and then add a constant. The opposite to differentiation, because if you differentiate this back, we'd bring the power down, which would cancel out, lower the power, and of course the c would disappear because it's a constant. So here I'm going to raise the power to 3 over 2, adding 1, half plus 1, and then divide by 3 over 2, which is actually the same as timesing by 2 over 3. If you want, you can write it as a fraction, you can use your calculator, but I'm just going to go this quicker route. And then we've got k and 1. That is equal to 28 over 3. So I'm good. I've got my little equation here. Right, that's going to become 4 over 3 k to the 3 over 2 minus 4 over 3 times 1 to the 3 over 2, which is actually just 1. And that equals 28 over 3. Okay, this is looking better. So that means 4 over 3 k to the 3 over 2 is going to equal 32 over 3 k to the 3 over 2. I can then times by 3 and divide by 4. So 32 over 3 times 3 over 4. These cancel. 32 over 4 is 8. And then k is going to be, because k to the 3 over 2 is 8, actually k is going to be 8 to the 2/3. You have to be a little bit careful here, because sometimes you can get a plus or a minus. I'm not going to here, but I might just put a little line in to be a bit safer. Let's actually write it as root k, because it's k to the half and then all to the power of 3. So actually root k cubed equals 8. So that means root k is 2. Then we square k must equal 4. I just want to explain what I meant by my the other thing I was talking about. Let's say I had k, so because you could in this case just say that k is 8 to the 2/3, put that in your calculator and you get 4. But if you had k to the 2/3 equals 4, for example, then you got to be careful. You can't just do 4 to the 3 over 2, because what this is actually the cube root of k squared is equal to 4. And in the process of taking the square root, we would actually get plus or minus 2, and then k would equal plus or minus 8. You could potentially lose that minus solution. So that's why I think it's just that's why I was saying basically be a little bit more careful, go along these lines here. In the second part of this question, got a trig equation to solve. Remember your trig identities. Tan, that's not actually going to come into play here, but I'm just going to write it down. Tan theta is sine theta over cos theta. That's a crucial one to remember. And the other one is sine squared theta plus cos squared theta is identical to 1. Okay, I'm just going to quote these here. I'm not going to show where they come from, but make sure you learn them and then you apply them. So I've got a cos squared and a sine. I'm want to get it all in terms of the same thing. So what I'm going to do is replace that cos squared by 1 minus sine squared. So 2 times 1 minus sine squared theta is equal to 1 minus sine theta. And what I'm actually doing here is creating a hidden quadratic in sine. I'm going to try and get the sine squared term to be positive, so I'll add that onto both sides. So 2 sine squared theta minus sine theta, and then I can also minus 2, so I get minus 1 is equal to 0. We're trying to solve between 0 and 360, we'll just bear that in mind. Let's see if it factorizes. Actually, you might be somebody who likes to do a substitution at this point. You can either just factorize in terms of sine, or you can say let u equals sine theta. Then we get 2u squared minus u minus 1 equals 0. Right, now this can be a little bit easier to see to factorize. So I'll have to put a 1 and a 1 in if it's going to work. I want a minus u, so I put a minus there. and a +1 there. So all checks out. U is equal to -1/2 or 1. If you're not comfortable with that, or if you just want to check, then of course there's this equation function button, polynomial, degree 2. We can type in that quadratic. It's got x there, but it's the same idea. -1 and -1. And we again get 1 and -1/2. Brilliant. So we haven't actually finished. That means that sine theta is going to equal -1/2, or sine theta is 1. Okay, let's talk about, remember we're solving between 0 and 360, don't forget that. So I'll deal with the one on the left first. I can do inverse sine of -1/2. Which gives -30. Now, it depends how you then do this next part. Do you draw diagrams or do you try and use cast diagrams? I like to draw diagrams. So I'm drawing out sine, and actually I've just found this solution here. So I want this one and this one, the ones between 0 and 360. So what I can do essentially is use the symmetry of the curve. It must be that this little distance here is this little distance here. I just need to do 180 plus 30. So my next one is going to be 210. And then the one after that, I can actually use the periodicity and do 360 add -30, which is going to give 330. You can use 180, because if you have a value, say here, you do 180 minus, you can still do that because it will get you the same place. So 180 minus -30 will also give 210. So sorry, there's a couple of ways of explaining it. Just going to take a look at the cast diagram approach. This is not what I normally do. Actually, I normally refuse to, but I'm trying to become a bit more open-minded. So the cast diagram talks about where each of the functions is positive. It's all sausages turn cold. So sine is positive between 0 and 90. That's here. And then 90 to 180, as you can see from the graph. Now we have theta as -30. That would be a solution. So I'm going to indicate that on my cast diagram here. Sometimes people just ignore the negative and put it and kind of figure it out from there, but I'm going to go with using the negative. And then I'm going to bounce it off like that because sine is also negative here. So I've got -30, and then what I actually want is a positive angle, so I need to go all the way around to here, so we can see it's going to be 180 plus 30 as before, the 210. If I want my other one, then I go all the way around to here, so I just need to, let me just write 30 there, or -30, but yeah, I just need to then do 360 -30 to get that one. So that's a little explanation using a cast diagram. We get the same answers. Sine theta is equal to 1. Actually, we can see there's only one solution from the graph. We're going to get 90. No need to do anything else from the cast diagram. We'd put it in our calculator and get 90, which would actually take us here. And it's right on the border. There's nowhere else where it's positive, okay, because it's in between. So if it was like here, then you'd do this one, but it's a special case where it's exactly vertical. So again, we see that there's just this one answer of 90. Those are all the angles between 0 and 360. So just to finish, I'm going to write theta is equal to 90 degrees, 210 degrees, or 330 degrees. Well done.